Okay, so in Mendel's time, it was one gene equals one trait. But in reality, one gene can influence many seemingly unrelated traits, and this phenomenon is what we call pleiotropy. So there's some classic examples of pleiotropy. One is Marfan syndrome. So it's caused by a mutation in the FBN1 gene, which codes for a critical protein needed for elastic fibers and connective tissue. So we see all the effects of this from having a tall stature, disproportionately long arms, legs, and fingers. You can have weakening of the aorta. You can have dislocation of your ocular lens and even show some abnormalities in your skin and lungs. Again, seemingly unrelated. Other examples, we've already talked about sickle cell disease that's caused by a mutation in the HBB gene, which leads to a defective beta globulin subunit of hemoglobin. So its effects, again, are very different. We have our erythrocytes that become sickle cell shaped in low oxygen conditions. We can have anemia due to the rapid destruction of our erythrocytes. We can have pain, we can have organ damage, and increased susceptibility to infections. Another example is going to be porphyria, and this is actually a group of disorders that's due to enzyme defects in the heme biosynthesis pathway. So the effects are variable, and they can range from photosensitivity to neurological problems to abdominal pain and even mental disturbances. So let's talk about linkage. So genes that are physically close on the same chromosome tend to be inherited together. So we say that these genes are linked. And yes, this does violate Mendel's law of independent assortment, which does assume that all genes segregate independently during meiosis. So an example, let's go back to our fruit fly. So let's say gene A controls body color and gene B controls wing shape. If both genes are close together on the same chromosome, the offspring often inherit the parental combination, like gray body and normal wings, more frequently than the recombinant ones, like gray body and vestigial wings. So during prophase 1 of meiosis, crossing over can separate these linked genes, and we have something called a recombination frequency, which is basically how often crossing over is actually occurring. And this is going to give us a clue to how far apart genes are located on a chromosome. So the closer the genes are located, the less the recombination. The further apart the genes are located, the more the recombination.